Jnanam paramam dhyayam. Knowledge is supreme.
Welcome to today's lecture on advanced transition metal organometallic chemistry. We have been discussing about transition metal cyclopentadienyl halide complexes. These complexes are part of sandwich complexes which we have been discussing in the last few lectures. We started off by talking about transition metal cyclopentadienyl carbonyl complexes, then went on to talk about cyclopentadienyl transition metal nitrosyl complexes. Then we went on to speak further about cyclopentadienyl transition metal hydride complexes, and now we are talking about transition metal cyclopentadienyl halide complexes. These all belong to the category of half sandwich complexes, and with regard to transition metal cyclopentadienyl halide complexes, in our previous lecture we had looked into various preparative methods that are available for synthesizing these complexes. It is worth mentioning that these transition metal cyclopentadienyl halide complexes are important precursor to many other cyclopentadienyl transition metal complexes, and hence these complexes have been synthesized to a great extent, and their reactivity also explored to a great extent. So, from that perspective we looked into various synthetic methods which were available for preparing these complexes, and also we have looked into the structure of cyclopentadienyl transition metal halide complexes. So, today continuing further on this discussion, we are going to be talking about something which are important derivatives or compounds which are derived from these transition metal cyclopentadienyl halide complexes, and in particular I would be talking about the transition metal cyclopentadienyl aqua complexes, which are indeed derived from these transition metal cyclopentadienyl halide complexes. So, today as a part of this discussion we are going to be talking about Cp aqua metal cationic complexes, and these are formed from Cp metal halide complexes under hydrolytic conditions. Let me illustrate this by the simple example of the reaction of cyclopentadienyl metal halide complexes of the type CpMXN, that reacting with NAg plus. So, now silver cation is used for precipitating this halide, abstracting this halide as a part of AgCl along with the formation of this aqua complex. The reaction that is why to be done in water would give this CpMH2O N plus NAgX as a precipitate. So, this is a nice reaction which involves the low solubility product of silver chloride or silver halide, utilizes that, and which is used to abstract these halides from this Cp metal X kind of compounds and freeing up a vacant coordination site at the metal, and that to be readily occupied by this water. Now, these are important organometallic compounds, and actually these compounds are both in nature, they are organometallic compound as well as coordination compounds. So, these are classic examples of species that combine organometallic compound and a coordination compound. So, the organometallic component arises from this Cp metal bond, and the coordination component arises from the aqua metal bond. So, these are pretty nice neat examples which combines both the aspects of organometallic chemistry and coordination chemistry, and all of them being present in the same metal species. Okay. So, now coming back to it, there are many complexes of these have been reported, and some of the examples that include are shown over here are BCP2 titanium diaco whole 2 plus, Cp chromium triaco two plus, Cp star M triaco two plus, M can be cobalt, rhodium and iridium. So, one important thing is that in this aqua reaction, that the halides are abstracted and then a vacant coordination site is formed, and that vacant coordination site is occupied by a donor ligand like water, resulting in the formation of these complexes. Now, if you look at the geometry of these complexes, as we had mentioned earlier, that Cp or Cp star sort of enforces pseudo tetrahedral geometry at the metal center, and that can be seen over here in all of the examples that we have been talking about. For example, in the first one there are 2 Cp and 2 water. So, there are 4 ligands around titanium in a pseudo tetrahedral geometry, whereas for the chromium there is 1 Cp and 3 water, again 4 ligands around the metal center in a pseudo tetrahedral geometry, as well as for in the last complex cobalt, iridium or rhodium and iridium, there also is 1 Cp star and 3 water, resulting in 4 ligands around the metal in a pseudo tetrahedral geometry. So, what we see is that these aqua cationic complexes are important class of compound by themselves, and which can be accessible from the half sandwich Cp transition metal halide complexes by simple abstraction of the halide using silver ions in aqueous medium. And these complexes are also classic examples of organometallic compound by virtue of having a Cp metal bond, and also simultaneously a classic example of coordination compounds by virtue of having water metal bond, and are quite elegant examples by themselves. Now, along this line we are going to see another very interesting compound which are also formed from this transition metal cyclopentadienyl halide complexes, and these are just transition metal cyclopentadienyl halide hydride complexes. These are kind of interesting, and these are popularly known as Schwarz reagent. And they are of the formula Cp2 zirconium chloride and hydride, and these are called mixed Cp metal hydride chloride hydride complex. Now, the structure of this compound is again in pseudo tetrahedral geometry as it is supposed to be, and it has tilted Cp the way it should be while we had discussed the other compounds. So that now this BCP zirconium chloride hydride complex, which is called Schwarz reagent, can be used for converting olefin to many other derivatives, which we will be seeing this. So, the first reaction of this Schwarz reagent with olefin like cyclohexane gives this cyclohexyl derivative, by a method called hydrozirconation. This is popularly referred to as hydrozirconation. And this is kind of evident from the fact that the zirconium and hydrogen adding against this olefinic bond. Now, this hydrozirconation like is sort of proceeds in a cis fashion, as would be expected from this zirconium hydrogen bond adding against this olefin from the same side, and similar to that of hydroboration or other cis additions that one is familiar with. Now, this zirconium cyclohexyl derivative obtained by hydrozirconation using Schwarz reagent can further be converted to many important organic compounds. For example, by treatment with D2O gives deuterated cyclohexane with the deuterium residing in place of zirconium. With oxygen, it gives the corresponding alcohol, and with bromine, it gives the corresponding bromide, cyclohexyl bromide, along with the formation of BCP zirconium chloride bromide, and subsequently this zirconium BCP zirconium chloride bromide when treated with lithium aluminum hydride gives back this Schwarz reagent. Now, thing which is to be noted over here, that when this mixed halide compound BCP zirconium chloride bromide treated with hydride reagent, the hydride formation does not happen at the chloride, but happens at the bromide, which sort of reflects the fact that zirconium chloride bond is even more stronger than the zirconium bromide bond, and as a result the bromide undergoes replacement, giving back to this Schwarz reagent. Now, we have been looking at some very interesting chemistry which are being derived from transition metal cyclohexyl transition metal cyclopentadienyl halide complexes. One such example are cyclopentadienyl metal aqua complexes. Then we saw these cyclopentadienyl mixed halide hydride complexes, which is sort of Schwarz reagent, which can convert olefin to so many useful organic products. Now, we are going to look at another useful applications of these halide complexes, which are just these Lewis acidic cationic complexes formed from the abstraction of the halide, similar to the aqueous complexes that we had earlier observed about. So, these are kind of strong, highly electron deficient molecules which are highly acidic, and in this context one has to mention about Jordan's cation, which is nothing but have the formula Cp2 zirconium methyl THF positive, and these is highly Lewis acidic cationic species which can carry out various kind of CH activations and CC couplings. And CC couplings. So, what we see is this Jordan's cations is a electron deficient Lewis acidic compounds, which can be formed from transition metal cyclopentadienyl halide complexes, and they are extremely good in various types of catalytic transformations, for example, CH and CC coupling reactions. So, before we talk about the reactivity of this, let me just first give the synthesis of this Jordan's cation as well Jordan's cation of the type these BCP zirconium dichloride with methyl lithium, and that results in lithium chloride giving BCP zirconium dimethyl. Now, this is these dimethyl complexes can be generated from the halide complexes by simple treatment with methyl lithium, and then comes this methyl abstraction reaction in THF, and usually this is done by using some kind of proton source like HNBU whole 3 plus and BPH4 minus, which eliminates NBU3 and methane, and the reaction done in THF giving Cp zirconium CH3 THF plus BPH4 minus. So, these complexes are cationic in nature and also are Lewis acidic in nature and have the general formula as Cp2 Zr R L, okay, as well as its base free form is Cp2 Zr R. These are strong Lewis acids and can carry out many kinds of catalytic reactions, for example, CH activation, CC coupling, even olefin polymerization. And so, an example of its ability for abstracting the base is given in the reaction Cp2 zirconium R L plus BF4 minus, giving Cp2 zirconium R F plus BF3 plus L. So, here is a demonstration of the Lewis acidic nature of this BCP zirconium RL, where this L gets replaced by the abstraction of a fluoride from BF4, giving this mixed fluoroalkyl zirconium BCP halide complex along with BF3 and the ligand. So, now this Jordan's cation is a useful species which has acted as a versatile active species for many catalytic transformations, and we are going to look at some of the examples on the same. So, for example, BCP zirconium methyl THF cation reacts with alkyne, where it undergoes this methyl zirconium addition, giving this olefin zirconium THF. It also reacts with CO, where the carbonyl incides into the zirconium metal bond, giving a zirconium acyl moiety Cp2 zirconium CO THF, and this oxygen is loosely the lone pair of oxygen is loosely coordinated to zirconium, zirconium being highly electron deficient species, and also reacts with olefin in form of olefin polymerization to give BCP2 zirconium alkyl species, where the long polymer chain is attached to the metal center. So, one can see the versatility of this Jordan cation which can carry out so many different reactions. Now, apart from all these reactions are called coordination insertion reactions. These are called coordination insertion reactions, which means that each of these alkene first coordinates and then inserts onto the species, whereas these Jordan's cation can also undergo sigma metathesis reactions, sigma bond metathesis with alkanes, and this is illustrated in the following beautiful example. Plus R H goes through this transition state eliminating methane plus BCP2 zirconium R L cation. So, L can be THF, then it is slow, or PME3, then it is fast. Okay. So, with this I would like to conclude upon today's discussion on transition metal cyclopentadienyl halide complexes. These are part of half sandwich complexes that we have discussed, we are discussing, and what we saw that these transition metal cyclopentadienyl halide complexes are important precursors to many other interesting compounds. To start with, we looked into the conversion of cyclopentadienyl transition metal halide complexes to the corresponding aqua complexes by simple abstraction with silver reagents, the abstractions of the halide in water. Now, these transition metal aqua complexes are interesting examples depicting simultaneous aspects of organometallic chemistry by virtue of the presence of metal cyclopentadienyl bond, as well as coordination chemistry by virtue of the presence of water coordinating to the transition metal. We have also seen how these halide complexes could be transformed to mixed halide hydride complexes and giving rise to this important reagent called Swartz reagent. Swartz reagent is an useful reagent for organic transformations, in which it can convert olefins to various derivatives upon reaction with this mixed halide hydride complex via hydrozirconation. We have also come across another very versatile catalytically active species called Jordan's cation, which is nothing but bis-cyclopentadienyl zirconium methyl THF cation, and this is a useful cation for many catalytic processes involving CH activation, CC couplings, as well as olefin polymerization. We have looked how this reaction proceeds, and primarily with various substrates like alkynes, carbon monoxide, alkenes. This cation proceeds by this coordination insertion mechanism, in which it first coordinates and then gets inserted into zirconium methyl bond. We have also seen that this Jordan's cation is capable of exhibiting sigma bond metathesis, and this occurs when these are treated with alkanes via a 4-member transition state. So, all of these chemistry further highlights or testifies the important versatility of Jordan's cation, and the so much of different reactivity of Jordan's cation can be traced down to their highly Lewis acidic nature, which allows for various activation of substrates, first by coordination insertion pathway as well as by sigma metathesis pathway. So, this highly versatility of Jordan's cation can be pegged to the Lewis acidity of this species. So, with this I would like to conclude today's discussion, which had been primarily on transition metal halide complexes and their reactivity. Still some of the topics are to be discussed, which will be taken up in the next lecture, and I thank you again for being with me in this lecture, and I look forward to being with you in the next lecture while we take up this topic and many more in more details. Till then, goodbye.